Hi everyone, my name is Evgeny Stemasov from Ulm University, and I'll be presenting the paper Mix&Match, which is generally a tool for personal fabrication aimed at omitting modeling as such. So let's take a look at a brief video of the prototype. So I can search a model repository, in this case for a hook. I can compare what I want to 3D print, and I can preview it and ensure that it is actually what I want to have later on, function-wise or maybe design-wise. So a bit of motivation. Personal fabrication is spreading and will continue to spread. So what do I need to use it successfully? I either need modeling skills to some degree, knowledge of some sort of software or workflow, or I can rely on model repositories with finished designs ready to print, sometimes parametric designs even provided by a community. So users then would browse, select and print whatever they want, which is more like online shopping and less like 3D modeling as such. So this leverages design effort that other users have conducted, and we also wanted to transfer all necessary work to the location where a future artifact is meant to reside in, so to every relevant work in situ. Let's try an example. So say I want to get a mount for my headphones, something to hang them from my wall, and I probably have the headphones right with me and the wall obviously too to measure and estimate, and I can go ahead and start modeling them, the mount, so maybe in a CAD tool like Fusion 360, which is a bit complex, but I'll get there probably. Or I could go for a simpler modeling tool like Tinkercad. I could work with simpler primitives, have a simpler interface, and I'll also get there nonetheless. Or alternatively, I could try to not model the artifact I need at all. I could search a repository like Thingiverse, find something that fits, maybe find a parametric design that I can customize. So this is the value of such repositories. They leverage outsourced design effort for novices and expert users alike. And they still permit changes and remixing, so I do not start from scratch anymore. But they do not necessarily account for my personal requirements. So in both cases I might have to iterate, choose a different design or redo my model. And we wanted to make this process a little bit easier. Now about these personal requirements, they are about the interaction of the object with its environment, with its physical context. So nothing I will ever make or 3D print will be levitating in empty space. So it may have some sort of functional interaction with its environment. Mechanical tasks like, is this hook mounted high enough? Is it robust enough? Is it maybe thin enough for my jacket to fit on? Or alternatively, it may have aesthetic interaction and fit. So this pot right there, does it fit the general theme or interior design of my own house? Is it appealing to me or not? So these aspects are not as easy to outsource than modeling alone. And this was generally the driving factor for the development of Mix&Match. So there are quite a few interesting works in the space, which had in part comparable motivation. First of all, mixed reality is an excellent tool to situate design and modeling work in the right context. So this was, for instance, shown by Peng et al., and it is also a very nice way to incorporate real-world objects into the process. So these works you can see here emphasize and embrace the notion of modeling, which we wanted to circumvent for the most part, and we wanted to leverage outsourced design effort as found in model repositories. So as you've heard in our motivation, the physical context is incredibly relevant. So this functional interaction was coined as augmented fabrication by Ashbrook et al. And there have also been systems that aim to integrate real-world objects into a design and modeling process. So I don't have to measure parts anymore. For instance, in the Mirage printer system, this might be my finger or a phone. FusePrint and MixFab are also very similar in that regard. And we wanted to embrace these concepts, but also focus less on modeling from scratch. Remixes are also important in community repositories like Thingiverse, so there have been some very interesting analytical works, especially from the perspective of beginners, but also powerful tools like Grafter that enable remixing machines found in model repositories. There's also a lot of going on in terms of 3D scanning meant to be everywhere. There are quite a few startups working on easy methods to digitize the real world, so at some point we may actually have detailed meshes of everything around us, and augmented or mixed reality are certainly drivers for that. So a bit about the concept we were aiming for. As mentioned earlier, we wanted to remove long modeling processes for 3D printing, but we also wanted to include and leverage the user's physical environment in a shorter in-situ remixing process. So this is how this process could look like. We'll iterate through that later with an example, but what's important is that it is in-situ and relies on outsourced design effort. Now, this in-situ pick-and-choose paradigm, as we called it, relies on the functions of mixed reality headsets. So such a headset like the Magic Leap or the HoloLens already provides some sort of scene understanding. So they generate an environment mesh, mostly for tracking and occlusion, and which is fine for their goals, but it is also an incredible opportunity. We might soon be running around with our very own 3D scanners, which allow some degree of interaction with this physical environment. So I might be able to copy and paste something, duplicate it. I might also be able to apply geometric operations based on these scans and repository models, for example. We're not quite there yet, but we might be in the future. So a bit of a more precise example. I might want to get a hook for a shelf, as you've seen in the first video. I could search the repository, find a nice one, verify how it looks like, and print it. Or alternatively, I already own one. I have it printed already or have bought it earlier, so I could maybe copy it, scale it up or down, and also get a design that works fine. What this means is essentially that I have this digital repository with me, but I also have a physical one available for features or for full objects to use for remixing. This is enabled by the means of spatial computing or mixed reality. Just as a side note here, you see a bit of an offset here in the screenshot. That's because of our recording method. To the person wearing the headset, the images are properly aligned. So let's talk about this prototype system that we developed. It was implemented with a Magic Leap headset, the ML1, Unity, and the API of MyMiniFactory. We chose MyMiniFactory because it is heavier curated than other repositories, for instance Thingiverse. It also employs some printability checks, and what we also do is we filter out all models that do not permit remixing in their license. Searching and downloading is implemented via their REST API. And the Unity app is responsible for rendering the models and the interface. And as you can see here, we interact with them in a combination of controller and gestures together. This is an example of scaling. So to illustrate the life cycle of a model, I select it as a download and instantiate it in the background. I can interact with it. I can export an STL, and the system automatically slices it, which you could, for instance, send to something like Octoprint. By now, we have actually updated the workflow to use more robust libraries, primarily for CSG, constructive solid geometry. We calculate a signed distance function, an SDF, for each mesh and work with that. The representation we see is the signed distance function converted back to a mesh via margin cubes. So about CSG, just an example, looks pretty much like this. We can select multiple volumes and, for instance, subtract one volume from the other. And many serious modeling tools rely on this exact concept, which we wanted to use primarily for remixing. So for instance, it allows me to remix models from the repository in place. So I could download two different ones and combine them, like this ring and this mask you can see here. Maybe I can even preview the ring right on my finger if I wanted to. But we also can go ahead and combine real features with repository models. For instance, subtract a real shelf from some sort of mount I've downloaded to get something like a press fit. So the Magic Leap scan sadly is currently too coarse, so we went and used marker tracking to position pre-modeled features like the section of the shelf you can see over there. So this is something we believe will be solved with increased maturity of these devices and maybe services focusing on providing such scans. Let's go over a brief example of how one could actually use Mix&Match. So let's say our task is that we want a pen holder for my desktop. I can type in my search terms, start browsing the results. Maybe based on the thumbnails, I can judge whether I want an object or not. And I can select any model I like, and it is downloaded in the background. I'm now gathering alternatives. They are attached to the controller. I can see and evaluate them in 3D, and I can remove any that I do not like. I can also reopen the search UI to find more, maybe refine my search terms. So I can now properly start previewing the designs in place and place them on my tabletop, compare them in size or in terms of design, maybe make some sort of aesthetic judgment, and I can start altering and remixing them, for instance scaling, which is pretty much the simplest remix procedure. I can also try, as one of the final steps, to verify my design coarsely, of course, which maybe I could take a real pen and put it in there, see how it fits in there. Maybe the holder should be a bit larger to avoid tipping over. All these aspects like that. And finally, if I confirm that I want this design, I can confirm it, save STL, generate G-code. This all happens automatically with sane defaults, probably not ideal ones, but we also don't want to make any assumption whether I print such things myself or whether it is sent to a service. This step is not inherently personal, so outsourcing it appears reasonable too. So to conclude, a summary and some open questions. So first, the limitation of our implementations. So like I mentioned, scanning is not fine enough provided by the device, so we essentially mock this aspect with marker tracking. We could also try to improve the search experience with, for instance, filters, voice input. Maybe I can even gesture a desired shape and get objects for that. There's probably lots of potential here. Lastly, model repositories often contain whole assemblies for 3D prints, one single file with multiple parts, and we didn't really expect users to assemble them just for previewing, so we filtered those out. We also found that some user-generated meshes were corrupted or had other errors, which software like Cura is often able to fix or ignore, but Mix&Match not always does so. So for future work, we first of all want to conduct some studies with the prototype, which is why we continue to improve it. We also want to implement some of the improvements to search. It is also intriguing to venture beyond shape remixing, for example, which is what we focused on here. Maybe mechanisms are also interesting to consider in an in-situ simplified design process. Lastly, we assume some sort of smart segmentation of scans of the environment, which may not be the case. So how do I actually copy and paste from one large mesh? That's also interesting to consider. So our contribution was the proof of concept implementation of Mix&Match and this notion of an in-situ pick and choose for personal fabrication with the aim to omit modeling from scratch if and when that's possible. So I would like to conclude with some open questions. What is it that is inherently personal about personal fabrication? What can we outsource and what are we unable to outsource, and what is it that we actually want or are willing to outsource? Can we actually omit this traditional notion of modeling from scratch with simple primitives while still getting incredibly personalized fitting results for our tasks? And can we really leverage past design effort while retaining agency over the things we make? So thanks for your attention, and of course for more details please see the paper.